All right, I'm back right away. So yeah, it now works. I rebooted my system and it works. I'm a little bit confused though because remember what I did right before it stopped working? I went in here and I did get the code dot and I opened it up. So it was working and then it stopped working for whatever reason. So hopefully that doesn't happen again. I'm not sure what went wrong there, but yeah, all I need to do is go into use case 7. Actually, all I need to do is start a Jupyter Notebook. Okay, and then I do need to start up the other things I had open, but this will automatically open the browser here. Okay, and then we need to go to use case 7, and we need to probably make the same edits as with all of them. So yeah, we need to change this over to a percent. We need to get rid of this cell. Let's just leave the cells in and comment them out. I think that's a better way to do it. Then, yep, we need to change it over to run locally against the author's intentions. All right, and we don't need the print statement there. Okay, so this is UC7, and then we need to change the import of sans. Okay, and that should be everything. So I'm going to do a control S on that. Sorry, get a ChatGPT ready to go, and then open the book, and now we can continue. So yeah, let's do a restart and clear all output on the kernel, and then try to get to that data frame, events data frame. Oh, so this is why I like to do this locally, because I want to see these errors and overcome them. So we've got a problem here. Getting requirement to build wheel did not run successfully. So originates from a subprocess. Likely not a problem with. Okay, so we've got no module named setup tools. Okay, I'm not sure what that is all about. I'll try running it again. We should get the same error. Yep. All right, so let's put this whole thing in ChatGPT. Oops, and it didn't put the correct information in there. Okay, so we'll do a copy, and then open a new one, and then paste. There we go.
Tools is update. Make sure that setup tools is updated to the latest version. Install setup tools _ rust. Since the error indicates that setup tools _ rust is being used and there's an issue with setup tools, command build try installing setup tools _ rust explicitly. Retry the installation. After updating setup tools and installing setup tools rust, try to install the transformers package again. Here are the commands combined for your convenience. If these steps do not resolve the issue, you can try installing a precompiled version of the tokenizers package to bypass the build process. Let me know if you encounter any further issues.
Okay, so we're missing a package here, so let's add it here and try it again. Okay, same problem. So there's other things we can try. We can try upgrading setup tools. So let's try that. Let's create a new cell, insert a new cell above. So insert cell above. And then we'll do pip install. And let's do pip as well. And let's see if this works. All right, so that works, and then we'll try this. Uh, Same problem. It looks like things are a little bit different now. So we're getting closer. Now this is Transformers sentence piece 451. Is that the same? It is. And then, so if that does not resolve the issue, we can try installing a pre-compiled version of tokenizers. Let's try that. So we're going to install tokenizers here and see if that works. Did not work. So we got tokenizers in there. We got setup tools -rust. But so let's look more carefully what the error is. So the error is specifically with this package. So as we're going through this package, we get a subprocess executed with error. So the subprocess is Python setup egg info. It did not run successfully because there was a package that was not found. It wasn't able to find a sentence piece. So is that spelled correctly? Let's see if the word sentence is spelled correctly. It is. Okay. PIECE looks right. So that's the first thing I wanted to look at. Let's go back and look at the example in the book. Okay, so the example in the book is just shows the code. It doesn't show those import statements. So we can't see what's going on there. Okay. But the problem is with this sentence piece here. The Transformers package, yeah, something about that isn't correct. So we're going to do a Google search for that. And then we're going to look in the actual PyPy repository where it's pulled down and see what's going on here. Oh, cool. Hugging Face has a cool... Hugging Face is a pretty big AI company. If you look at job postings for AI, it probably still will be like this. You'll see Hugging Face is hiring a lot of people. So it's definitely one of the companies at the very edge of development that's trying to grow this community of AI developers. So it looks like they have a free course on here. So this might be something really good to go through on this channel at some point. All right, so let's click on release history, and then let's find the version that we're trying to use. We're trying to use version 451. Okay, so we're trying to use a very, very old version. We're trying to use one all the way back from 2021. I don't know if we have to use that version or if we can use a newer one. So I don't see anything regarding sentence. I guess what we could try doing is importing it without the sentence keyword and see if that works. So we're just going to do this and see if that works. Okay, so we still got the same problem. It's just the tokenizers package itself did not run successfully. So you know what? Let's forget about that old version and let's just try to work with the... Oh, you know what? Let's get rid of... let's get rid of everything except this. We can get rid of this cell as well. And let's see how that works. Okay, so now we have the actual Transformers package from Hugging Face. So let's just proceed with that, and if there's any problems, I'll troubleshoot and resolve them, and that's what I want, the content I want to be on this channel anyway, so it's kind of a win-win. Okay, moving on. We've changed it to use case 7. This is good. This is good. This is good. This is good. This is the thing that might take a long time. So if it takes a long time, then we'll have to uncomment this line here and then pull in the pre-made file. And this line we can just uncomment. We don't need to create the file. We don't need to overwrite the pre-existing file with the ones we generate. So it looks like there's an error here. We've got no module found, so let's install that module. All right, so now we're doing our training run. So we've got the index constructor will not infer so this is just a future warning. Doesn't matter. It's from pandas itself. So some return. Yeah, okay. But, yep, seems to be working. So let's give it a few minutes. And if it's still working, we'll uncomment this line here and pull in the existing results of this training and work with that. We have around 8,100 logs in our data set with 4 different types of severity: warning, error, critical, info. In case there is a not a number value in any of the messages, we will apply a quick filtering to eliminate them. This is something you should always remember when dealing with data you have collected. Problems happen, and some data may be missing, and unless you explicitly check, you may not notice. All right. So we're explicitly checking the data. If we observe the logs, they have different formats. They have numbers, special characters, and a variety of strings. This is purely text data. However, machine learning algorithms cannot work with text data. They only work with numbers, so we need to transform this into numbers somehow. With that goal in mind, we first need to evaluate if we need the entire string as it is. Let's remember that the more data you push to a model that is not strictly necessary, it is just making the process more complex and eventually making it more difficult to converge to the desired result. So it's really important that you only work with the data necessary to accomplish your goals. Otherwise, you are adding to the complexity of the processing. A good practice, as we discussed in the theory, is to remove what is somehow superfluous or does not add enough value. Punctuation characters is one good example of that. So let's get rid of them first. We will also remove the numbers. Numbers in our context are not critical to determine the nature of the log, which is what we want to do. They are informative by all means, not to classify the log, but to extract information from within it, which at this point we are not looking in this use case. Therefore, we will also eliminate numbers. All right, so here's everything we're eliminating. And then, so we go through this 4, and then we replace it with nothing. The clean log list looks like the skeleton of the original logs, and that is the intent, to keep only what we believe is strictly necessary. Now we need to decide how we are going to transform these logs into numbers for our classification. A very well-known and basic technique for text classification, which we introduced earlier in this book, is bag of words. It is the mechanism by which each text, and in our case each log, will be transformed into a vector. The length of the vector is the length of the dictionary, all the different words detected in the input data set, and the value in each position in the vector is the number of instances counted for such words. Effectively, it is a bag of words, and it tends to be quite effective to determine the nature of a text and compare them. And one thing I want to do before continuing forward is check. Oh, cool. So we can work with our own generated one. So let's take a look at that. All right. And then I also want to bookmark this course because I think this would be a really good course to go through at some point. So we've got the introduction here. So let's go to welcome to this course and make a bookmark under technical development. So we're going to do edit. We're going to do folder, choose another folder. And then we're going to go not hobbies. We're going to do career technical development courses. All right. For this purpose, we will use count vectorizer from scikit-learn library. When we train this class with the input set of logs, we obtain a matrix that has as many words as logs and as many columns as different words have been detected. All right, there we go. There we go. Looks good to me. So yeah, let's get that cell to print out. So this yeah, we're gonna see this structure here. Okay, so here's the logs, and notice that the logs have all the punctuation in them. So that's not going to be relevant information. What we want to know is do these messages change from one log to the next? We want to know things like, is this a BGP log? We want to know if the state changed to up or down. But the punctuation, we don't need to know. Now, one thing I will say is if we remove all the punctuation, we're not going to be able to read IP addresses anymore because we won't be able to tell, is this IP address 1.1.87.12 or is it 111.71.2? And then that's not even taking into account the fact that we have this 30. So it could even be 11. It could even be 118.71.230. So it could even be a valid IP address with this as part of the IP, and then the subnet mask isn't even given. That could be what it actually is meant to be if we look at just a string of numbers without the punctuation. So the punctuation does change a lot. And the other thing is when it comes to interfaces, the tunnel interface here, the Ethernet interface here, we don't know if this is actually, if we remove these dashes, we don't know if it's tunnel interface 72-1 or if it's tunnel interface 7-21. And yeah, in some cases it could be self-evident. For example, E11, there's probably no E11 on the device, and this is typically how it is. But if it were E110, if it were E111, you wouldn't know if it were E11.1 or E111. So you do need to be a little bit careful and really think about what data is relevant. Because when you do something like remove all of the punctuation, that can affect some of the data in a way you didn't plan for or didn't think about. So if you're trying to get those interfaces, if you're trying to get IP addresses, just removing all the punctuation probably won't work for that. But I don't think that's what we're trying to do. So let's move next to the next cell. So here's all the punctuation we're going to remove. So for log message in log list, and then for character in here, we're going to replace all the characters with a space actually. So I think this is a typo. I might need to I might need to fix that. And that's not what the... Oh, you know what? I think a space is fine. Yeah, and we're also removing numbers as well. We can see re.sub for nothing there. So yeah, this is how it's meant to go. So those IP addresses, those port numbers, we're just getting rid of them. We don't really care about which port or which IP, but we do know whether it's an ET, whether it's a ton. So that's the only information that is relevant. All right, and now we're caught up with the book. Based on our input dataset, there are 104 different words in the dictionary. Since it is a classification use case, one important step is to evaluate if the classes we have are balanced or not. When they are not balanced, this may likely lead to wrong results. If that was the case, we might need to apply techniques to rebalance the classes. All right, let's get to that graph. All right, and their graph had colors, mine doesn't, so I don't know if I'm just off track here. Yeah, so it looks like there's something different about my graph versus theirs. The colors didn't register. So there's BNB, count plot, severity. Oh, so this is a bit of a different graph. Okay, so yeah, this is good. Let's get down to this here. Okay, so I'm a bit ahead now. Fortunately, our dataset is reasonably balanced, so we will not take any specific action. If at all, we could eliminate some info messages to make sure the input is fully balanced, but we will not do it for now. We are going to prepare our data now for the classification model training. There we go. Note that while we have transformed the input data to numbers, we have not transformed the labels to numbers. You could think that this should be necessary, but many libraries will do that for you in the background. However, in some cases, you will also need to transform your target labels into numbers by yourself. In this use case, we do not need it. We need to separate our dataset in training and testing so we can evaluate the performance of the model with unseen data. The train test split function, and this dash is no good. It's not s-split. It's indicating that it word reps. I think. No, it is, because we can see it right here. Function is very commonly used. It will extract random samples with the specified size, ensuring fairness in the label distribution. For example, the training and testing data will have the same or very similar distribution. The first model we are going to use for classification is random forest. We have seen in the theory it is a very powerful ensemble classification algorithm that will build a large number of classification trees. There we go, looks good to me. Now with the model trained, we can evaluate with the test data. Okay, ytest PRED. Okay. The resulting vector contains the labels in the same string format as we provided initially. If we evaluate the performance of the model, we can see, as per the capture below, that it is behaving optimally. This is not a surprise. We have a reasonably small and simple dataset, so the model is able to capture to the perfection. To be honest, we could very likely think that it is overfitting, or that we have not truly provided a test set that is different from the training set. From the training data set, we have 8,000 logs, but only about 15 types. So the testing set is likely a repetition of what is already in the training data set, post cleaning of numbers and punctuation. There we go, looks good to me. Now let's try to challenge the model a bit to see how well it performs with truly unseen logs. Let's pick one log message from our table, which in this case has severity critical. All right, so we're going to pick one out, a log message 428. All right, so we've got a severity of critical, which I don't see written there. Now we create a new log by introducing some modifications on it. And let's evaluate the model with this new log. We need to apply the same cleaning and vectorization as before in order to present the log to the model for classification. The model has assigned the same severity to the log above, which is the desired and reasonable result. You can try to introduce further modifications to logs and see what happens. Now we are going to make use of our friend brute force to not only try various models, but do cross-validation. Cross-validation will run multiple instances of the model with different parts of the data as training and testing. The goal is to train different instances of the model with different data and see overall what is the result on average. In this case, each model will do 10 times cross-validation, and we will train 3 different models: linear support vector classification, naive Bayes classifier, and logistic regression. I've not picked these for any particular reason. This produces a table with 1 row per model training execution with its results. The summary is as follows. It seems that naive Bayes is the least performing of all 3. All right, so and we know that it's the least because of this accuracy here. So naive Bayes. Oh, well, where's naive Bayes? Oh, well, I don't know. I don't understand this because I don't see naive Bayes on there. Anyway, let's get to that cell. Oh, so it's down here. Okay, so we can suppress the warning pretty easily, but it didn't take that long to finish. There we go, and now let's get the scores of the models. So linear SVC, multiloma NB got 0.92. In the book, it got a 0.88. So I think it got a higher score on mine. So maybe my hardware's a bit. Okay. So let's go to ChatGPT. ChatGPT is pretty good for this. The only problem is I don't know how accurate this is. But what I want to ask it is, look at this screenshot and create a tier list for the scores of different model names. Include the scores and models seen in the screenshot in the tier list. Okay, so they got perfect accuracy.
Here's a tier list for the scores of different model names based on the data from the screenshot. S tier, perfect accuracy, linear SVC 1.00.
Okay, now expand out the tier list with opinions that would come from an expert in this knowledge domain.
Sure, here's an expanded to-list with expert opinions. S tier, perfect accuracy, linear SVC 1.0000000 expert opinion. Linear SVC, or linear support vector classification, is performing exceptionally well with perfect accuracy on this dataset. This suggests that the dataset is linearly separable and the SVM is effectively finding the optimal hyperplane to classify the data points. It's important to validate these results with a test set to ensure it's not overfitting. Logistic regression 1.0000000 expert opinion. Logistic regression also achieving perfect accuracy is a strong indication of a well-separable dataset.
That doesn't seem useful to me. Anyway, moving on. Now we are going to explore a different angle. Previously, we had done a real classification by training a model with existing data. There is a growing field of opportunity. There might also be a growing field. I'm not sure about that. Around zero-shot / one-shot / few-shot classification, which is based on leveraging pre-trained large language models, LLM. These LLMs have been trained with such a large amount of data that they have the ability to find semantic similarities across multiple types of texts offered. That means you could use a sentence as a string and labels as other strings, and ask the model to provide the degree of similarity between the sentence and each of those labels. This is effectively doing a classification. If we use the label for which a higher degree of similarity has been found, let's explore this in practice. As LLM, we are going to use some transformers from the Transformers library from Hugging Face. You can try other models yourself. The following command will download the model we select, BART large MNLI in this case, and there are other models to choose from, and as the author says, you can play with the other models, but I'm not going to do that. I just want to get done with this. So here we go. This is where we're choosing it, and this might be the moment of truth where we had those import issues. So let's hopefully this will work. And there's another model to try here that's commented out, but I'm just going to try that one model. So we've got a widget. JavaScript is not detected. So it may not be installed or enabled correctly. Reconnecting to current kernel may help. So attribute float progress object. So there's something going wrong with my browser. So let's reconnect by. Oh, okay, changes will not be saved. What happens if we restart? All variables will be lost. Okay. Okay. Well, this is interesting. I don't know what to do. If it almost sounds like it wants me to refresh the browser. Well, you know what? Let's do that. So we're gonna do restart and clear all output. Then we're gonna do a refresh with a we're gonna do a refresh like this. Control R for refresh. But let's do a restart and clear all again. So that goes down to 0, and now we'll do a refresh. We'll reload without saving the changes. Okay, so now it's weird. Okay, but there we go. Looks good to me. So let's get all the way down. All right, and I forget exactly where I need to go down to. Classifier equals pipeline. So right here. All right, so then in the meantime, I'll keep reading. Now let's start asking the model. We can request similarity scores between an input string and a set of strings, namely the labels we want to do zero-shot classification with. See the following example. All right. Our sequence above expresses a possible log message or application generated alert about a server having a high CPU utilization. We have requested the classifier to provide a classification score with a number of words that somehow identify the type of problem this message is about. The model has clearly indicated that this is, with all probability, a processor issue. We never trained the model specifically for this type of log message or these classes. The similarity which the model is able to compute due to the vast amount of data it has trained with, can serve us a good enough classification with zero effort from our side. We did not need to collect a dataset, clean it, train a model, etc. Now let's give a try with our log messages and our severities and see what we obtain. It seems a BGP session down message is classified by the model as info. We should not expect the results to match what we have defined in our dataset. That would be overfitting. Now, if we make up a log message emphasizing that the network is down, let's see what the model produces. It seems now more severe, and it is classified as an error. We can play a bit more with the language to take the log message language to a bit of an absurd level to see if the model will assess the severity properly. It seems the model has clearly interpreted the new condition the log describes is truly a critical situation. While assessing the severity of the log is a bit subjective, and most of the time these language models will not necessarily deliver a good result, we could use them though to make an interpretation of what type of log or message it is and maybe route it accordingly. The following is one example. We tend to have a classification on whether the log refers to a hardware or software issue. Seems the model is accurately pointing towards a software issue. The following is also correctly labeled in this case as a hardware-related issue. All right. Okay, so same thing. Float bar object has no attribute style. So, blah, 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 blah. Let's just try the other model. Why not? Now, I don't think this will solve it because it's just the other model. So, like, the thing that is actually creating that progress bar is the result of calling that object pipeline, or this is running this pipeline function here. So, I think it returns that thing that's going wrong. So, I really don't think changing the model will solve the issue. Now it went a lot faster this time, which is great. And yep, so config.json, widget JavaScript not detected, it may not be installed or properly or enabled properly. So let's feed all of this to ChatGPT. Now maybe it has to be run in Firefox, something like that.
The error you are encountering suggests that there is an issue with the progress bar visualization in the Jupyter Notebook environment.
Yeah.
This can often happen due to incompatibilities between the TQDM library and the Jupyter Notebook widget environment. To resolve this, you can try the following steps. Reinstall IPY widgets. Ensure you have the IPY widgets library installed and properly configured.
Alright, we can try that.
Disable the progress bar. If you don't need the progress bar, you can disable it by setting the disable parameter to true. Using a different progress bar style. You can try switching the progress bar style or using a different method to visualize the progress. Updating TQDM. Ensure you have the latest version of TQDM. If these steps do not resolve the issue, consider running the code in a different environment, e.g., a standard Python script outside of Jupyter, to verify if the problem is specific to the Jupyter environment.
Let's do that. Let's get rid of the progress bar. So we're going to use the original model, and we're going to add a parameter at the end. And we don't need to see that progress bar. All right, so hopefully it runs at that warp speed again. I don't know why it was running so much faster there, but hopefully that continues. And yeah, this should solve the issue. If not, then I can try I can try some of this stuff. Oh yeah, so it's running at that warp speed again. Cool. All right, so even though we did Java stall progress bar equals false, we still had the issue. So let's remove this, and then let's try the other things that ChatGPT said to try. Okay, so let's try adding. All right, so let's do this. We're gonna shut down the notebook, and then we're gonna run these commands to make sure everything's installed correctly. And that did not work. Let's run the commands one at a time. Oh, and I'm noticing something kind of odd here. We actually don't have the virtual environment activated, so I don't know what happened there. That clearly needs to be activated. Okay, we got permission denied, so we'll do a sudo. All right. All right, so now that extension should be good to go. So we'll open the notebook again and run use case 7. All right, there we go. So, so I still have progress bar equals false there. Shouldn't make a difference. I guess I'll delete it and then save it. Maybe that makes a difference for when it runs. Now it looks like it just added itself back automatically. So let's try doing a delete on it again. Okay, and then we're gonna do a Control S again. All right, and it looks like it didn't magically add itself back, which is good. But unfortunately, the JavaScript widget still was not detected, even though it took that effort to install it. So let's do some of these. Let's do another strategy here. We're going to yep. So we already tried progress bar equals false. That didn't work. So let's try this next. And TQDM, that should be imported somewhere in that second cell. Well, I don't see it. All right, but that's okay. So next thing we're going to try is to add some, to add some more code up here. And now try running this cell. All right, so transformers is not defined. So we got to do import transformers. Oh, so same problem. Widget is not detected. Okay, so another thing we can do is a help on pipeline. So let's do that in a new cell. So we're going to do insert cell below, and we're going to do help on pipeline. Okay, so okay. So there should be something about disabling a progress bar. Or like something about setting it to false, maybe? Okay. Huh. Yeah, I don't see anything regarding that, so not sure what's going on there. So let's feed the help to ChatGPT.
The error you're encountering seems related to the progress bar visualization in the Jupyter Notebook environment. This issue can often occur due to incompatibilities between the TQDM library and the Jupyter Notebook widget environment. Let's focus on setting up a pipeline correctly while avoiding progress bar issues. Here's an updated approach. Ensure you have the necessary libraries installed. Ensure you have transformers and TQDM installed. If not, you can install them using pip. Use the pipeline without progress bar. You can create the pipeline and pass a parameter to disable the progress bar if needed. Avoid using the notebook's progress bar. If you still encounter issues, you can disable the progress bar or use a different method to visualize the progress. Update your Jupyter widgets. Make sure your Jupyter widgets are up to date. Here's a complete code snippet with the recommended changes. By following these steps, you should be able to use the pipeline for zero-shot classification without encountering issues with the progress bar in Jupyter Notebooks.
Okay. Interesting. Yeah. I mean, obviously this was gonna fail because we had to change it from sentence. Um. Yeah, it was supposed to be Transformers sentence to a certain version. Yeah, so now we get this same problem. Same problem still. All right. Oh, you know what? It said this all the way back here. Float bar progress has no attribute style. So this is on line 195 in color return for TQDM. And this is, yeah, so when we import TQDM, uh, okay. So there's something wrong with this. Let's put this in there in ChatGPT.
The error message you're encountering is related to the TQDM progress bar used in Jupyter Notebooks. This issue can often be resolved by ensuring the correct versions of the required libraries are installed and by avoiding the usage of TQDM environments where it might cause issues. Here's a step-by-step solution to resolve this issue. Ensure the correct installation of libraries. Make sure you have the latest versions of TQDM, IPY widgets, and transformers. Disable progress bar in the pipeline. Modify the pipeline initialization to disable the progress bar. Disable TQDM in Jupyter Notebooks. You can also globally disable the TQDM progress bar in your notebook.
Oh, how do I do that?
Here's a complete example code. By following these steps, you should be able to use the pipeline without encountering issues related to the progress bar in Jupyter Notebooks.
All right, so let's try this. So we're gonna add a cell below. All right, run that cell. Okay, so we added something there. We added the widgets. So let's try running this cell again. And then go all the way down and try to run this cell again. Nope. Okay, and it's not a log message, it's an actual error in the program. All right, let's try this. Huh. Okay, it didn't work. So it didn't work. It just did not work at all.
The error you're encountering is persistent and related to the TQDM progress bar implementation in Jupyter Notebooks. Since previous attempts to disable TQDM progress bars globally didn't resolve the issue, a different approach would be to install a different progress bar package that is compatible with Jupyter Notebooks, such as TQDM Notebook. Here are steps to resolve the issue. Install TQDM Notebook and IPY widgets if not already installed. Use TQDM. Notebook explicitly. Update your code to use TQDM. Notebook for the progress bar instead of the standard TQDM progress bar.
Okay, that's not working. That's not working. Shoot. Kernel died. Okay, now it can't even. Oh, you know what? It's because I ended it. There we go. Alright, this one's a particularly difficult one to solve. Alright, and then we'll put this cell more or less back to how it was and try running it. Alright, in the meantime, we'll keep on going. This probably might not work. Chances are, if you try other examples, you may get unexpected results. I am not trying to state here these models are perfect, but it is an area of opportunity to leverage zero-shot classification for logs or application messages in a way that could be automated, but without the burden of building and maintaining a machine learning model ourselves. You can even take this to the next level, as some of these LLMs are now hosted by their creators and offered as a service via an inference API. You can run one-shot classification having literally zero infrastructure on your side, but it may have a cost per query. Now let's give a try to the latest and greatest LLM, OpenAI's ChatGPT. ChatGPT is an evolution of the GPT-3, which has been boosted with reinforcement learning and human-based labeling. You could think of a GPT-3 on steroids that has been optimized to respond more precisely as humans expect. I made a few questions to ChatGPT along the lines of the previous queries around zero-shot classification, but in this case expressed more as natural language queries. The log message is CPU utilization is over 92% on server with that server name. Which out of the following categories is this log associated to? Processor, memory, storage, connectivity, or authentication? And the answer appears to be processor because it's CPU utilization. ChatGPT. This log message is associated with the processor category, specifically CPU utilization. It is indicating that the CPU usage on the server named that is high, possibly indicating that the server is experiencing a high workload or maybe experiencing a performance issue. See, honestly, I don't think that's a very impressive response. The response is quite impressive.
Here's how you can
ChatGPT.
modify your script. Disable Jupyter widgets if the issue persists. If a problem still exists, you can completely disable the progress bar within the Transformers library for all operations.
The response is quite impressive. ChatGPT has never been exposed to this log message before. Let's try some more examples. See, I don't think this is that impressive, and it's all right there. It didn't have to infer anything. It literally says it's CPU. Like if you were to hide this, honestly, if you were even to say the utilization is over 90% of the server, and if you were to hide this word there, I'd be more impressed. But I'm really not impressed by this. Because one thing, I haven't been all that impressed with ChatGPT in general, because I've tried to build an application where it's a browser application and it gives like spinny diagrams in it, and ChatGPT has not been able to enable me to do that. It's just doesn't, and we can see here, it's not giving me it doesn't know what my problem is, and it's just regurgitating puke that doesn't work. It's like I'm impressed by ChatGPT, but I feel like it can 10x your work, but it can't 100x your work, and it certainly can't 1,000 or 1,000,000x your work. Like what it's best at doing is giving you kind of clues to work with and reminding you. It's like, oh, I forgot what that command was, and it can tell you what that command is. Basically, it's marginally better than Googling for answers. All right, so here's some more examples. The log message is thus: is this a software or hardware issue? And we can see, so ChatGPT, this log message is not related to either a software or hardware issue. It is a security log message generated by the secure shell SSH daemon SSHD, indicating that a user has logged out from the VTY terminal. Okay, so that's kind of impressive. The log message includes information about the user and the source of the logout. It is labeled as an info message, indicating that it is simply an informational message and not an error warning. Yeah, that's definitely pretty useful. ChatGPT is extracting information from within the log message as if it was familiar with its structure. Here's another example of that. The log message is thus: for device, is this a software or hardware issue? So let's see. So it says infra shelf hardware failure event, hardware issue. ChatGPT, this log message is related to a hardware issue. It is generated by a process called Shelf Manager and includes the label that, indicating that it is a hardware failure event. The log message includes information about the hardware event and the reason for the event. It also includes information about the affected device and its hardware revision. This log message indicates that there is a hardware issue with device C2, possibly due to a power failure or some other issue with the input to the device. So yeah, that's pretty useful. But again, all the information is right there. It's not telling you anything, and it says it right there. No input or power. So it's like if you can't get the information you need from this, why is this any more useful? It's telling you the same thing. I'm not that impressed. It is really exciting how ChatGPT is automatically extracting structure from the log messages and providing a human readable view. Is it though? I mean, what's so unhuman readable about this? There's not enough spaces for you. Like this is human readable. In the next example, we address one traditional challenge in network operation. When multiple alerts are correlated, how to express the information in a way that is human consumable. So this interface is down, BGP is down. Give me a summary of what happened. And we know the summary of what happened. This interface went down. It was serving as an interface for which a BGP connection, was established. So that BGP connection went down, and it also was serving as an interface for which an OSPF adjacency was connected. So that went down as well. It's all right there. It appears that there was an issue with the interface ET1/1/0, which caused it to go down. That's what this word means. This may have caused the Border Gateway Protocol BGP neighbor 1034.1.5 to also go down, as well as the Open Shortest Path First OSPF adjacency on that interface. It is possible that this was caused by a hardware or software issue with the interface ET1/1/0, or it could be due to a problem with the connection or communication with the BGP neighbor or OSPF adjacency. It would be necessary to investigate further to determine the root cause of the issue. That is not impressive to me. You cannot convince me that that is impressive. All it is doing is regurgitating what is said here in different words. How is that impressive? If it gave me a list, like a checklist of troubleshooting, that could be pretty impressive. If it automatically goes and executes that list and gives me the command output, that could be impressive. If it gives me like the BGP table, if it automatically can log into this device through its management IP and show me what happened on the other side, that would be impressive. But this does not impress me at all. In fact, it disappoints me greatly, because it's teaching people that in order for something to be human readable, it has to be in complete sentences. It has to. It's like, no, this is a professional working message for professionals. If you need this to be put in a different format than what you see here, you do not belong on this device. Log out now. Like, leave it to the pros. Like, please. So, yeah, not only does this not impress me, it seems like it could enable an unsafe environment. Surprisingly, ChatGPT appears to have semantic awareness that the BGP or OSPF issues are due to the port down event. That's not impressive either. And is providing a lightweight root cause analysis. No, it's not. It says... This could also be due to the ordering, of which the list of events has been presented. Let's see what happens if we change the order. Okay, so now we're going to give me a summary of what's happened, and we change the order to say that the BGP neighbor went down first, then the interface went down. See, but the thing is, like, you altered a message. You can't do that. Like, the order matters. You can't do that. Like, this is not a valid message that would show up. You can't just do that. Like, let's throw in another issue there. Let's say that the firmware update failed or something like that. It's like, it's not a valid message. You can't do that. So here's the response from ChatGPT. It appears that there was an issue with the Border Gateway Protocol neighbor 1034.1.5, which caused it to go down. This may have caused the interface ET1/1/0 to also go down, as well as the Open Shortest Path First OSPF adjacency on that interface. It is possible that this was caused by a problem with the connection or communication with the BGP neighbor, or it could be due to a hardware or software issue with the interface ET-1/0/1, that interface there, or the OSPF adjacency. It would be necessary to investigate further to determine the root cause of the issue. Yeah, and that's the thing too, is like it's making this assumption based on the order of the events. So yeah, what this demonstrated was that it doesn't understand what's going on. It's just making an assumption there that the ordering of the events matters, which sometimes it does. It might. So it was clearly driven by the order of the events. Still, the response is quite logic. I don't know what that means. There are areas to improve, but large language models like ChatGPT and their consumption via API have strong potential to help network and cloud engineers in daily tasks. Even today, some of the responses are already mind-blowing. I mean, I agree with that. I've gotten some pretty mind-blowing responses from ChatGPT. They're rare. This is not an example of a mind-blowing response. But I agree that there's potential. As I said, if it can give you a short list of troubleshooting, what causes, what do you need to check to, why did this interface go down? How can you go, like if it shows you a more log messages, it logs into the device, runs some commands, it logs into the other side of this neighborship. If it places a phone call out to a tech, there's a lot of potential behind this, but people already do that. Like, all it's doing is taking the reins away from a human who's better than it and doing it in a bad way and not understanding what it's doing. Like, it's not an AGI. Like, humans are AGIs. So yeah, I'm not impressed. If it becomes an actual AGI and can do things to or above the level of humans, I will be impressed. But by that time, we've invented some technology so superior, so vastly capable and superior to humans that, like, it's like, what does it matter that this technology exists? Because I will never interact with it. Like, by the time it becomes that sophisticated, it has no need for me. Like, hopefully it will be designed in a way aligned to my interests and help me live a better life. But I think a lot of what AI is being developed for today is military applications. So that doesn't seem likely to be happening. So I think it's designed to try to kill people and dominate and take away power. So I think that's ultimately what it will probably do, is just render humanity as extinct and find a way to self-sustain itself over time, or just become extinct as well. So I think we're all going to die. I agree with Eliezer Yudkowsky. But I don't think that means we should shut it down. Let's bravely go forward. And if we become extinct, then fine, we deserve it. Takeaways. This use case has been an introductory one. Oh yeah. This use case has been an introductory one for the fascinating field of natural language processing. And this is where I think the author is ESL. He's from Spain. So a better way to write that would have been, this use case has been an introduction to the fascinating field of natural language processing. Key takeaways I would like to emphasize. Data representation is the key in NLP, natural language processing. How you transform text into numbers, that will be presented to a model. There is always a strong level of cleaning of the data in NLP, stop words, punctuations, numbers, etc. Bag of words, a simple but effective technique to classify texts. Large language models represent a good opportunity to address log and application message classification, leveraging the approach of zero-shot classification. All right, and let's check back in on the thing that's annoying. Haha, look at that. So I don't know what I did, but we got further. We got the progress bar to go all the way through. But we do have another problem here. The runtime error. So we failed to import. So we've got Keras 3, but we need to install the backwards compatible TF Keras instead. So let's do that. And we can do it all in the cell and just keep going forward. We don't have to clear out everything and start again. So we'll just edit the cell. You know what? Let's just add a cell above it. All right, and then run this. And run it in the magic method so it installs in the kernel. Kentucky Fried install here. All right, and now hopefully this will work. Progress bar works. I don't know what I did. There was a widgets option here where we could clear the notebook widget state. I did select that without saying that out loud. Maybe that made a difference. We did a lot of things, so I don't know what worked and what didn't at this point, but all I care about is getting it through. We don't need this cell anymore, so I'll just comment it out. Okay, we're at 100%, and but it's still not filled in with a number, so it's still working. And I'm going to kind of ruin the suspense and pause it and go and get a glass of water. Oh, you know what? No, it's cool. So we fixed it. I don't know how we fixed it, but yeah. So we got a few things here. This is from the the kernel was built without NUMA support. It was cannot open some GPU libraries. Okay, whatever. Yeah. So it's my hardware is installed to run Witcher 3 and not AI models. All right, so now we do. It's interesting. We do have a plt.show here, but no graph printed out. So I'm not sure what's going on there. That seems to be an issue. Okay, but we do have something that looks like what I remember reading earlier in the book. We're quite a bit behind, but yeah, okay. So things are working now. And there we go. We've got all these beautiful graphs here that are making the world go around. Yep. Those are some graphs for sure. No doubt about it. Anyone who questions whether or not this is a graph could be right because it's a histogram, but a histogram is a kind of graph, as far as I know, unless it's a separate category of graph. But yes, Walt, let's verify. Is a histogram a type of graph? Oh yeah, proven all the doubters wrong. All right, so let's move on to further work. There are many other classification algorithms that could be tested. One area to explore would be to use your own network log messages and apply the same exercises and see the results. And that's great because that's another thing. If you're a junior, if you're an intern even, if you're still in school, you could try this. Get your real work done. Don't break everything. Get your work done in school and get the good grades in school. Don't waste your time in school because you're paying for the results of finishing it. So if you never finish it, you're especially not getting a good deal. But you got to pick your program carefully and make sure that you're learning. You just kind of got to put your blind full faith. You got to do your research that you've entered the right program in school, and then from there, just blindly do what they tell you. All right, but there are many other classification algorithms that can be tested. One area to explore would be to use your own network log messages and apply the same exercise and see the results. Another area to explore is using zero-shot classification to get labeling of a number of log messages, which then you can use to train your own classification model given the labels you have obtained from the LLM. And that's it for use case 7. Use case 8, what log messages is expected next? All right, so let me advance the bookmark and delete the old one. And then, yep, so we got the notepad file open. We got all the cells to run successfully. Hooray, even though it was a little bit strained at times. So when I be back, we'll be diving into use case 8. So thanks for watching, and see you in the next video.